Welcome to the Stellar WIFI Analyzer training. In this video, we will explore how to transform your Stellar access points into advanced sensors for improved RF analysis, real-time monitoring, and Wi-Fi optimization. Stellar Wi-Fi is a trademark of Alcatel-Lucent Enterprise, ALE. All other product names and trademarks mentioned in this document are the property of their respective owners. Stellar Wi-Fi Analyzer is the exclusive intellectual property of Fernando Rivas Blada. Our agenda covers the Wi-Fi connection process, key RF attributes, and the impact of wired services. We will also introduce the Stellar Wi-Fi Analyzer Tool, its integration with OmniVista, and guide you through installation and deployment patterns. Part 1 focuses on the Wi-Fi connection process. We will examine how 802.11 clients discover, authenticate, and associate with an access point before any data frames are exchanged. A Wi-Fi connection is established through a series of steps: scanning for networks, open authentication, association, the security handshake, and finally, the DHCP process to obtain an IP address. Troubleshooting is most effective when you know where to look. This 4-layer model links application, IP, and authentication issues to specific diagnostic tools, allowing for more targeted problem resolution. From the device signal monitor to the Ethernet capture, the SWA tool will give you deep visibility and understanding about the quality on your Stellar Wi-Fi deployment, allowing you to identify the root cause of invisible problems. In Part 2, we move beyond simple signal bars to look at the real RF attributes that dictate performance, such as signal strength, noise floor, and signal-to-noise ratios. It is important to distinguish between signal and noise. RSSI measures the client's signal strength, while the noise floor represents environmental background energy. Monitoring these metrics is essential for maintaining a high-quality link. Signal-to-noise ratio is a definitive indicator of physical layer quality. Additionally, tracking TX retransmissions helps identify packet collisions or path fading, which are critical metrics when troubleshooting performance degradation. Channel utilization is a key factor in shared medium performance. SWA uses 68% as a critical trigger threshold, as contention delays and latency spikes often grow exponentially once a channel reaches this level of occupancy. Use this reference table to quickly determine the health of your RF environment based on metrics like RSSI, noise floor, SNR, retransmissions, and overall channel utilization. Part 3 covers the impact of wired services. We will evaluate how infrastructure components like DHCP, radius, spanning tree, and power classes directly influence the overall Wi-Fi experience. Wired onboarding services are critical. Failures in DHCP or radius authentication are common causes for connection issues. Capturing Ethernet packets on the switch port can help isolate these server-side or configuration problems. Physical foundations like switch port configuration and PoE budgets also play a significant role. Ensuring the proper tagging or untagging traffic and providing adequate power are all required for optimal AP and radio performance. Part 4 introduces the Stellar Wi-Fi Analyzer Tool. It is an elegant, browser-based solution designed to pull ALE Stellar AP hardware directly using secure protocols for effective, real-time troubleshooting. The SWA architecture is both passive and direct. It utilizes secure SSH polling to query APs without needing agents, providing accurate, real-time visibility and analysis into your network to quickly identify and address radio anomalies, Ethernet anomalies, or performance anomalies. The SWA core feature engine provides a comprehensive set of tools, including device signal and channel utilization monitors, connection log analysis, packet capture capabilities, and full visibility into your access point configurations. In Part 5, we will demonstrate how to use SWA with OmniVista. We'll show you how to translate raw telemetry and the analysis of this data into actionable optimization steps to resolve complex coverage, interference, or capacity issues. When monitoring device signals, you can track RSSI, noise, channel utilization, retransmission rate, data throughput on a rolling loop. If the data reveals poor margins, you can take action in OmniVista by adjusting transmit power, enabling band steering, changing the minimum data and management rates, or rerunning the RF plan. With the DSM device signal monitor, you can easily follow any Wi-Fi client device when roaming from one AP to another if all those APs within the roaming area are been monitored by the SWA tool. You can save and replay any monitor event using the monitor replay function. To optimize channel utilization, analyze congestion during peak traffic. If you identify a saturated band, consider pruning 2.4 GHz radios in high-density areas disabling legacy rates, enabling the 6 GHz band, or reduce the channel width to improve airtime efficiency. Combine this monitor with the CCI and ACI interference monitor analysis, and you will have a better understanding about your channel conditions. The clients connected and the connection log analysis (CLA) functions give you a full visibility and understanding about the overall signal and connections quality, analyzing real-time and accurate information related to the radio environment such as RSSI, noise, SNR, or retransmissions. The CLA, that stands for Connection Log Analysis, give you total visibility on the entire connection process, identifying graphically in which stage the failure occurred, that 90% of the time is for some DHCP or radius problem disguised as a Wi-Fi problem. Following this structured optimization workflow, from establishing a baseline and assessing channel utilization to performing deep dives, log tracing, and applying fixes, will ensure your network remains efficient and healthy. Key takeaways for the SWA tool include its ability to provide real-time RF data, facilitate forensic capture for offline analysis, and create a closed-loop system where metrics directly inform your OmniVista configuration changes. Part 6 covers the installation and upgrade process for the Stellar Wi-Fi Analyzer, whether you are deploying it on a virtualization host or running it via container images in a local environment. You can deploy SWA as a virtual machine, which is recommended for most production environments, or as a Docker container, which offers a lightweight, portable alternative for testing and development. For virtual machine installations, import the OVF files for the VMware platform or the Hyper-V disk files for the Hyper-V platform. Ensure adequate CPU and RAM resources are allocated, and verify your disk storage configuration for both the OS and the SWA application files. 2 disks must be imported. When using Hyper-V, make sure to select Gen 1 as the VM type. Once the VM is running, access the web interface via port 3005. If you need to change the default static IP address, you can do so by editing the interfaces file through an SSH connection using the root credentials. For Docker deployments, use the provided run command to pull the latest image. This command maps the necessary ports and configures the container to restart automatically, ensuring your analyzer remains available after system reboots. Updating SWA is simple. Virtual machines with internet access update automatically at startup. For Docker deployments, you must manually pull the latest image and restart your container to apply updates. To start your analysis, navigate to the connection panel and enter the management IPs of your access points, along with the correct SSH login credentials to initialize the discovery process. Finally, refer to this deployment matrix to compare the resource requirements, onboarding complexity, and upgrade methods between VM and Docker modes, helping you choose the best configuration for your network environment. Thank you for watching this training session. If you have any additional questions about deploying or using the Stellar Wi-Fi Analyzer, please feel free to reach out to the tool creator, Fernando Rivas Plata, at the contact information provided.